Hello and welcome to a video on mechanics paper 2019. It was question 3 and I'm putting this under the planes and forces category because let's face it, there's only really 5 question types they ask in the mechanics paper. So okay, I mean, this is a pulley question that often confuses students, and it's an inclined plane. Students don't like that. They don't like doing the prep work. Like here, tan alpha is 5/12, so sine alpha is 5/13, and cos alpha is 12/13, and that's because if you draw a little right angled triangle out and call that alpha, you know that tan alpha is opposite over adjacent, and therefore by Pythagoras that's 13. I recognised it as a Pythagorean triple. So sine alpha is opposite divided by adjacent. So sine alpha is opposite divided by hypotenuse, and cos alpha is adjacent divided by hypotenuse. Always do the prep work on these questions. Read it carefully. I think it says a plane is rough, and the coefficient of friction between A and the plane is 2/3, so that's mu. And we're going to show that the tension is 12 mg over 5. Well, honestly, lots of these questions, these pulleys questions, you can get loads of them from the old M1 past papers, but they always work the same way, really. You've got 3 mg pulling that for weight down, tension pulling it up. On the other side, you've got a tension pulling it up, you've got a weight pulling it down. Now, you might wonder to yourself, which way is this falling? In which case I would point out, well, ignore the tensions because they're internal forces. I'll quickly put the reaction on, but this has nothing to do with it. If you're looking about whether this goes that direction or, that direction, if you see what I mean, like down or down the slope, well, just compare the force going down the slope, which is 2 mg sine alpha, which is a number less than 2 mg because sine alpha is less than 1, 2 mg sine alpha, and compare that with 3 mg. Clearly 3 mg is stronger, and so this is going to go in that direction. That's a useful test, that really is. And so as it's a rough slope, friction will oppose the direction of motion in that direction. Okay, so let's set up our equations. Equation of motion for B, let's do the easy one first. Stronger force minus weaker force equals mass, which is 3m, not m, times acceleration. Similarly for A, stronger force this time is T, and the weaker forces are F max and 2 mg sine alpha. And that equals 2ma. Now we want tension, so why don't we times this all by 1.5? This is how I'm going to do this. And that way I can actually just equate the two equations, so I can get rid of, I can basically, get rid of the, I don't want to get rid of the, what do I want to do? Oh yeah, I want to keep the t's, so I want to get rid of the a's. So if I make this 3ma and 3ma, I can equate the two and I'll have everything in terms of t. So this second equation, A, if I call it A times 1.5, then I'm going to have 1.5t minus 1.5 F max minus 3 mg sine alpha, and that's going to equal 3ma, because I'm trying to find in this first question the tension. It's worth 8 marks, so it's going to be a bit of hard work, isn't it? What I can do now, as 3ma is both of these expressions, I can equate the two. 3mg minus t equals 1.5t minus 1.5 F max, well, we'll deal with that in a second, and then minus 3 mg sine alpha. Let's write that down. Okay, let's collect the t's together. 2.5t. Apologies, that's going off over there. It's a bit unnecessary. We've got 3 mg on this side. My handwriting. 3 mg on this side, but we've also got plus 1.5 F max. Now, let's quickly do some other work. R is going to be equal to 2 mg cos alpha. And that's just because the ups there are going to equal to downs because it's not bouncing. And so R is actually equal to 2 mg times by 12 over 13, which is 24 mg over 13. But as F max is mu R, it's 2/3 times that, and that's 16 mg over 13. And so I can now write down this as plus 1.5, well, let's call that 3 over 2, let's be grown up about it, plus 3 over 2 times by F max, which is 16 mg over 13. What else are we adding over here? We're adding a 3 mg sine alpha. Let's move this all up a bit. we're adding a free mg sine alpha. Sine alpha was 5/13, so that's going to be 15 mg over 13. Okay, hopefully this all works out. Let's call that 5/2 and be grown up about it. We've got 3 mg plus, okay, let's just simplify this. That's going to be 1.5 times 16 is 24 mg over 13. And then I've got 15 mg over 13. And this is where you just cross your fingers, really. That's 39 mg over 13. 49, 59, 63 mg over 13. 78 mg over 13, I think, altogether, which equals 5/2t. And so t is going to be equal to 2/5 times that. Obviously, use your calculator in the exam, but hopefully this cancels to 12 mg over 5. Okay, let's have a look at if it does. Slightly nervous moment. Okay, 13s into 65, 78. Yeah, this is actually equal to 78 over 13 is going to be the same as 6, because 6 times 13 is 60 plus 18, 78. Yeah, so that's equal to 6. And so this is 12 mg over 5. Yeah, feel free to use your calculator though in these questions, obviously. I just thought I'd work it out. The calculator's slightly out of reach at the moment. Okay, so after B reaches the ground, A continues to move up the plane until it comes to rest before reaching P. Okay, determine whether A will remain at rest. So it's skidding up, string's gone slack, yeah, it skids up, and then it's a case of will it go back down? Well, this is when we can do that little test I did at the start to decide which way it goes. Basically, you'll have this situation. The string will be slack. And now the friction's going in the other direction because it's about to move down the slope. Yeah. Now we don't know if it's at a maximum, but we know that the maximum available is going to be equal to mu times r. And as r is still, that was 20g, wasn't it? I think. Let's just quickly check. 2 mg, sorry, not 20g, 2 mg. 2 mg, and that's alpha there. Yeah, so not much has changed because f max is still going to be 2/3 times by r, and r is 2 mg cos alpha, and that obviously equals, that's 24 2/3 16 mg over 13, just like it did before. This is all calculations we've already done. Now what we want to do is we want to compare that to the force down the slope, which is 2 mg sine alpha. And 2 mg sine alpha is 2 mg times 5/13, which is 10 mg over 13. And so is the force down the slope stronger than the possible force up the slope? No, because we could have 16 mg over 13 acting up the slope, and hence as 16 mg over 13 is larger than 10 mg over 13, object will not slide down, because the friction's too strong. It will only take a value sufficient to oppose the movement, i.e. it will take a value of 10 mg over 13, but that will stop it sliding down and forces will be balanced. And so there we go. Part C suggests 2 refinements to the model that would make it more realistic. Okay, well, how about we have like a string which is extensible? You could do that. They'll accept that. You could obviously not, or you could take the weight of the string into account, but you could also consider the dimensions of the particles, because I think they've been treated as particles. Let's have a look if it says that specifically. Blocks are modelled as particles. So take weight of string into account. Consider dimensions of the box. There's lots you could have here. Have a look at the mark schemes for more, accuracy. But you could make sure the pulley had friction. Friction on pulley. There we go. So there's lots you can say there. So that's it. That's that question done. Hope you found it useful. Keep up the good work. Bye bye.